Hi everyone, welcome to my channel Talk and Do Physics. In today's lesson, we are going to explore the magic and wonders of physics concepts behind distance and displacement through hands-on engagement and activities. Through hands-on engagement, we are going to use this toy car. Oh, this is a police toy car. We are going to use this toy car to explain the deeper understanding the relationship between distance and displacement. And also, if you are traveling from one place to another, what is the distance covered? What is the displacement? So we are going to use this toy car to explain the distance and displacement. For instance, if this car is like this, there's no distance created. But if this car has an extension created a distance, that means the car has an interval, and the interval the car has, that is the total length between the two cars, is what we call distance. And we'll also go into displacement. Before we go into displacement, imagine you leaving your house to school. You are creating a distance. And what is the total distance covered? And what is the displacement? You are leaving your office to work. What is the displacement? Or you are leaving your house to work. What is the displacement? Or for instance, you are a taxi driver and you have seen a passenger telling you, I'm going to a city A or a city B. You need to know as a taxi driver, what is your distance and what is the displacement you are going to cover. So in this lesson, I'm going to teach you how to calculate distance and how to solve problem on distance and how to use distance to determine and apply to real life situation. We are going to use only 15 to 20 minutes to explore the world of distance and displacement. Before we go in, let's dive into the main issue. Physics behind distance and displacement. Physics behind distance and displacement, the key point we are going to consider and you should be able to understand after the lesson is 1. Distance. 2. Displacement. 3. You are going to also consider the distance between 2 points. Between 2 points. The distance between 2 points, and you also consider the position in a space. We consider the position in a space. We consider problem solving. Problem solving. In problem solving, we will consider how to calculate the total distance and displacement. Before the end of the lesson, you should be able to understand what is distance. You should also be able to understand what is displacement and what are the units of displacement and how do we derive displacement in a setting of a real life scenario, and also the total distance between 2 points. You should also be able to understand that, and you should also be able to understand position in a space and problem solving. So in this case, we are going to start by distance. Distance, before we know the definition of distance, this is a toy car. Like I've already explained, I have to come back again so that you should be able to understand what I'm going to teach you. This is a toy car and there's no distance created, as you can see. These two toy car, for right now, you have seen the space, the interval created by the two toy car. That is what we call distance. If, for instance, this is a car, let me make an illustration for those of you who want to write it down. This is a car. Don't mind my handwriting. Though my handwriting is very fine. This is a toy car A, and there's another toy car B that is here. And the distance between, this is B. If you measure the distance, the length between these two cars, that gives you distance. The length between these two toy cars gives you distance. That is what we mean by distance. In the real definition of distance, we will say distance is the measure of the total length. Is the measure of the total length of an object. Distance is a measure of the total length of an object. Or we can also say distance is the separation of objects between 2 points. Between 2 points. Distance is a measure of total length of an object. Distance is a separation of an object between 2 points. We already say distance is the total length. And also the SI unit, that is the standard unit of distance. SI unit is in kilometer, which is kilometer, and also meter. That's where it is being measured. Kilometer and meter. Kilometer and meter. And also, distance is a scalar quantity. Distance is a scalar quantity. We all know that, not a vector quantity, because it doesn't have a direction. It can only have a magnitude. Distance is a scalar quantity, and distance is a positive value. Distance is a positive value. And as you can see, we have been able to understand what is distance. So if you are going out and you want to apply distance, this is how to implement the definition of distance and how to calculate on distance. So let's dive into the calculation of distance before we get into displacement. For instance, we said a car travels 7 kilometers and then 8 kilometers, 7 kilometers and then 8 kilometers. For instance, we can say, let's use the directions north, 7 kilometers north and 8 kilometers south. What is the total distance? What is the total distance? The total distance will be, because first and foremost, sort out the parameters and the variable. This is 1 and 2. And you now say total distance equals to, let's use the short form so that we can be able to still understand, since we have already defined what distance is, equals to L1 plus L2, that which is equals to 7 plus 8. 7 plus 8 is equals to 15 kilometers. That is the total distance. So as you are able to understand the total distance covered, that means that that is a distance. So, and don't forget to write the unit of the distance, because that signifies the unit of the distance. So we are going to enter displacement. In displacement, we have a car. For instance, we have a car. We have this car. You want to see the displacement of this car. If I on this car now, the car will change its position. When the car changes its position, that is distance. When the car changes its position from one point to another, that is what we mean by distance. For instance, we have distance is the separation of position from initial to final position. And we have the initial position. For instance, this is the car, and this is the car. This is the tire of the car. This is a car. I like using that. This is the point A, and this car is moving to a point B, and the car stops here. This is where the car stops in a specific direction. In a specific direction. That is what we mean by displacement. So we now say displacement is the total distance covered in a specific direction. The total distance covered in a specific direction, or displacement is the change in position of an object in a specific direction. So as you can see, displacement is a separation of position from initial position to the final position. Like we illustrate a car moving from a point A to a point B has created a distance, and that is displacement. Displacement is the total distance covered in a specific direction. Displacement is also a change in position of an object in a specific direction. And displacement is a vector quantity. Displacement is a vector quantity. So as you can see that we have been able to define displacement and also illustrate how we can get displacement. So we are going to check the calculations on displacement. For instance, we have example 60 kilometer due north. 60 kilometer due north. And we want to illustrate this in a diagram. This is the axis of the north, and this is this. We have this, and the displacement, this is the north, is what? This is here, this here. This is 60 kilometer due north. And we may also have 24 kilometer east. Let's change the direction. This will be 24 kilometer. This is where it starts, and this is the distance he has created. The distance will be, can use it as a dot line in order to differentiate from the real line. This is the east, and this is 24 kilometer. That is the displacement. So, and like I've said, displacement is also measured in kilometer, meter, and it is a vector quantity. And also, if we are to calculate, we have been able to solve the displacement and the distance. We have been able to solve the distance. We have been able to solve distance and displacement. Now, we are going to solve questions on distance and displacement. We said a car travel 10 kilometer north, and then 12 kilometer south. What is the total distance and displacement? Solution. First and foremost, sort out the parameters. The parameters is 12, 10, and 12 kilometers. So the total distance is what? Total distance is L1 plus L2. That is means 10 plus 12 equals to 22 kilometer. That is the total distance. And for us to calculate the displacement, you know, it is a change of position from one point to another. We can call this, since we use L as distance, we can use P as displacement. Displacement is change in P. Change in P is what? P1 is 10 and P2 is 12. So we now have kilometer. So we now have P2 minus P1 equals to 12 minus 10. This is equals to 2 kilometer. That means that is the displacement of the car. So the displacement is change in P equals to P1 equals to 10 and P2 equals to 12. Change in displacement is P2 minus P1. How do we derive this? I still need to explain it. This is a moving car and this is a car. Here is 10. The car moves from 10 kilometer to 12 kilometer. That is the distance of the car, 12. So what is the displacement? The displacement is the change P1 and P2. So the change in P1 and P2 is what we call displacement. So any questions that is given to you on how to solve displacement and distance, you should be able to do it properly. Now let's dive into position in the space, because all what we are talking about is position in the space. Position in the space. When we talk about position in the space, for instance, we are talking about if an object is in the atmosphere, it has a position. Even this dot has a position. And this position has a coordinate. And the coordinate is X and Y. The coordinate of a position of an object is X and Y. So we now have, for instance, we have this object here, and the position of this object in my hand is X and Y. Let's use this police truck to illustrate the position of an object. This position in my hand has X and Y. X is the horizontal axis and Y is the vertical axis. So we are using this car as we have doing it now, using this car, and it has the Y direction and also has the X direction. When it has the X and Y direction, we call it the position. And in X direction, it is what we call Cartesian plane. It's what we call Cartesian plane. So now what we are going to do now is, for us, because it has an X and Y direction, it has position in the space, has X and Y direction. An aeroplane, for instance, in the space has X and Y direction. Even a car that is at rest has X and Y direction. Even as you are sitting down watching me, you have an X and Y direction. Even as I'm standing, I have X and Y direction. That is what we mean by position. And if we move from one point to another, this car moves to this point B. This point is what we call frame of reference. Frame of reference. So if you may ask, what is a frame of reference? Don't feel bad to say you don't understand it. Frame of reference is when you are moving from a point 0 to another point and you are referencing back to the first point. The initial point is what we call frame of a reference. That is what we call. So in position in the space, we have a coordinate X and Y, and that X and Y has to do with X1 and Y1. So we are going to use this to calculate X1 and y1 to calculate the distance. Distance between 2 points. The distance between 2 points in x and y coordinates. This is one of the questions WAEC normally asks. This is one of the questions they normally ask in JAM. This is one of the questions they normally ask in SAT examination and other national examinations. So I'm going to leverage the question from one of the national examination. For instance, they said that find the distance of a car between 2 points. Let's use like that. Between 2 points, A is 2 and 4, and B is 6 and 8. You are asked to find the distance of a car between 2 points. Remember, we're talking about x and y coordinates. So in finding the distance, find the distance of a car between 2 points. First, step 1. Sort out x and y values. That is x and y value. A, this is x1 equals to 2 and y1 equals to 4. And also in B, this is x1, we have x2 equals to 6 and y2 equals to 8. That means you have been able to sort out the x and y value. The next thing is for you to do now, step 2, is for you to bring out the formula for finding the distance. What is the formula for finding the distance? Formula for finding the distance is distance equals to square root of x2 minus x1 bracket squared plus y2 minus y1. That is the formula for finding the distance. Now what you need to do is to substitute these values into this equation. Substitute the above value into the equation, or call it formula, into the formula, because it's a formula. Into the formula. So we can now see, when you see x2, you replace by a figure. When you see x1, you replace, and that is step 3. Step 3, when you have x2, you bring out s equals to x2. Where do we have x2? x2 is 6. x2 minus x1, this is a sign of s, distance equals to this, plus, what is the next thing? y2 minus y1. This is y2 and this is y1. You now say 8 minus 4 squared. Now step 4, you are going to solve the inside before you now use the square root. S equals to 6 minus 4 gives you 4. So 6 minus 2 gives you 4. You square root. 8 minus 4 gives you 4. You square root. You have to square it. Now we now have step 5. This is equals to 4 times 4 gives you 16 plus 4 times 4 gives you 16 again. So we now have s equals to square of 16 plus 16. This gives us square of 16. We have to solve the inside first. This gives us, that is the step 6. 16 plus 16, 32. So that is the square root of 32. 5.6. You can approximate s equals to 6. Could be the square root of 32. So you have been able to understand how to find the distance between 2 points, A, 2 and 4, and B, 6 and 8. In other things, they may give you other distance to calculate, and you should be able to calculate it very well. For instance, let's you try SAT question. This question comes from SAT 2019. We say find the distance of a truck A or between 2 points A, 2 and 1, and B, 4 and 2. So when you have, like I've said, when you have this formula, nothing you should do than for you to say step 1, solution. Step 1, sort out the variables, which is A, this is x1 equals to 2, y1 equals to 1, and B, x2 equals to 4, and y2 equals to 2. Now in the another step, which is step 2, you bring out the formula, and the formula derived from the Pythagoras theorem, which says that distance equals to square root of x2 minus x1 plus y2 minus y1. And your next thing is for you to substitute the value into this formula. Step 3, you now said, when you see x2, what is the value of x2? 4. Now said 4 minus, what is x1? x1 is 2. You bracket, you squared it. Plus, where is y2? y2 is 2. And where is y1? y1 is 1. You square it. Then, you squared the figure. Now, step 4, you need to solve what is in the bracket first before you get to the square root. So, step 4 is s equals to 4 minus 2 is 2. The square root of 2, that is a 4. Okay, let's use 2 here, plus 2 minus 1 is 1. 1 squared. Then square root. 5. This is still solve what is in the bracket before the square root. This is the square root of this times 2 times 2 is 4 because it is square root, plus 1 times 1 is 1. That is step 6 equals to 5, the square root of the 5. That is the answer. The square of 5, that is the answer. So in some questions, you may be asked to find the distance covered between 2 cars. Finally, I hope you copied it. Write it well. Finally, let's get to backward and forward displacement. Back forward displacement and backward displacement. It will now say that this is the position of a car. For instance, this is a police car. The police car is here and is moving to another point, creating a distance B. Then the distance created is 400 meters. And the car is returning back to its original position like this. This cam car has returned back here. So this is positive because when it moves forward, it is positive. When it returns back, it is negative. So we are going to calculate the net displacement. If you have been asking in your JAM, your WAEC, what is the net displacement of a car traveling? So this is the forward displacement is 400 plus, because it is the same distance it's taking to return back, nothing has decreased. This is still 400. So we are going to say minus 400. This is because 400 plus times minus give us minus. So we now say 400 minus 400 give us 0 meter. So that means that the net displacement of this car is 0. So if you are asked what is the net displacement of a car, it's 0, because if it has to return back from its original position as we move forward and return back backward, that is the net displacement, that is a 0. As you are watching me, please remember to subscribe, share, as this should motivate me to do more exciting video. In another video, we are going to enter into distance, speed, and acceleration. So you need also to pay attention and move on with the next class that we are going to do. But I want to let you understand that before we end up the class, this distance and displacement is used in real life situation. For instance, the Greek, the Babylonians, and the Egyptians, they were using the foot and the feet to make measurements. Isaac Newton and Galileo Galilei was the one that used Newton's law of motion to create a study of distance and displacement. So that is what we are using now. Even the GPS that you are using. For instance, you said, I want to travel to my uncle's place as a student from, for instance, UK to Canada, and your friend says, what is the GPS? GPS, what is the global position system of your traveling? You might not understand. For instance, they say it is 1,500. What is the total distance of that your GPS, of that you're traveling from your destination? You should also be able to understand. So I am leveraging this, teaching physics behind distance and displacement for you to understand. Now, I want to also, for you to go and read further. Any questions you bring to the next class, we'll be able to solve it together and make it very simple. Thank you.